Okay, so today we are going to be graphing using intercepts. And so the nice thing is all that stuff that we've been doing is sort of, it all plays into this. So there's not a whole lot of new going on in this lesson. So when we go to graph these, first find the end behavior, because once you find the end behavior, you already have an idea of what your function is going to look like. All right, so nothing new there. Find the zeros. Sure. All right. How long have you guys been finding zeros? Long time, all right? Again, set it equal to 0, factor, figure out where the zeros are. Find y-intercepts. How long have you guys been finding y-intercepts? Long time, okay? The next part, do a sign analysis. We have done some of this when we were working with like our absolute value inequalities and the quadratic inequalities. So remember when we're testing regions and we plug a value in to figure out what you're going to get to see if it fits. The sign analysis is very similar to that. And then the last piece is to just take all that information, put it together, and sketch in the graph. So again, all of this stuff you already know, we're just going to put it all together now to produce the image. All right, so here is our first example. So we've got f of x equals x plus, or sorry, x times x plus 3 times x minus 5. All right, and they want us to find all the relevant information and then do the graph. So, what did we say we should be looking at first? Before the x-intercepts. End behavior, okay, because again, that's already going to give us an idea of what the graph should look like. Alrighty, so to determine end behavior, we look at the what? The degree. Alright, what is the degree of this function? Third degree. So we have a third degree, which means that's odd. And do we have a positive or negative lead? It's a positive lead.
Wait, I thought the degree was the number above the x.
Well, it is. Oh. Right now we're in factored form, so we have one here that would multiply to this one here that would multiply to this one here. So in the end we would have an x cubed. Okay, so what do we already know about the two tails of this function? Opposite directions. The right side should go up and the left side should go down. So I usually put that sketch in there just to remind myself. So that's just in case I make a mistake along the way. I have something to look back to and say like, oh, hold on, it shouldn't, should look similar to this. Okay, now we want to find the zeros. And what is so nice about this function here? It's already factored for us, so not a lot of work to do here. Let's just find our zeros. Okay, so what are our zeros? 0, negative 3, positive 5. All right, I'm going to go ahead and plot those. 0, negative 3, and 5. Right, and then we said we want to find our y-intercept. What's nice about this one? It's already there because we had a 0 of 0, so the y-intercept is 0. We don't have to do any extra work there. And then the last part, the sign analysis. So before I go into the sign analysis, again, I already know that my right tail should go upward in the positive direction. So I'm not going to spend time doing sign analysis on the right side because this is already doing that.
Wait, how did you find out the y-intercept?
Well, it's because we have a 0 here already.
Oh.
Yeah. All right. And what do I already know about the left tail? It's going down. So again, I'm not going to spend any time doing sign analysis on my two ends. So now I just need to figure out what is going on in between. All right. So I'm going to look at the first region to the left. What is a nice easy value over there? -1. Right. So I'm going to look at f of -1. And because I'm doing sign analysis, I'm not going to plug -1 in and actually solve for it. I'm going to plug -1 into the factored form and just determine if it's going to give me a positive or a negative. All right, so our first piece is x. If I plug in -1 there, I get a negative value. For the next one, when I plug in x here, -1 for x there, I get -1 plus 3, which is a positive value. And for the last one,
negative.
If I do -1, I get a negative value here. So that's the third one. So negative times positive times negative is a positive, which means it should go up, and then what's going to happen though? At some point it's going to turn around. I don't know exactly where. It's going to turn around and come back down to that 0.
You just choose a point.
Yep. Now I'm going to choose another point. What's a nice easy point?
3.
I'm going to stick with 1. 1's easier. All right. So if I plug in 1 for the x, I get a positive. And for the next one, 1 plus 3 is a positive. And for the next one, 1 minus 5 is a negative. I have positive times negative, and that is a negative. Which means in between, I should go down, and what's going to happen? It's going to turn around at some point and go back up and go through. So the next thing is, again, when we're talking about putting it all together, is just making sure that you have a nice smooth curve, especially on the turns. All right, what do we think of that one? Beautiful. See, I told you, we've already done all the hard stuff. All right, are we ready for the next one? Yes. Okay, here we go. All right, so for this one, we have f of x equals x cubed minus 2x squared. All right, and so again, we said, what do we want to determine? End behavior. Okay, what degree is this function? Third degree. So again, that makes it odd. Positive or negative lead? Positive lead. Okay, so again, since it's odd and positive, we know the right tail should go upward and the left tail down. All right, what do we want to find next?
Zeros.
The zeros. Okay, this is not factored for us, so we're going to have to set this up equal to 0. So x cubed minus 2x squared. We can factor out x squared, which leaves us with x minus 2. So what are our zeros? And anything else we need to say? Yes, 0 has a multiplicity of 2. And our last one is 2. All right, so I'm going to go ahead and plot these. I have a 0 here. I'm going to widen my scale just so that you can see a little bit better. Okay. This one worked out nicely for us again, because what is our y-intercept?
0.
0. No extra work there. Okay, so this time I only have 2 zeros. And again, I don't want to spend time doing sign analysis on the outside because I already know if I go to my rightmost y-intercept, what direction should I be going? Up. So we already know we're going up here. And from the left one, we should be going down. So now there's just the question of what is happening in between. Okay. So we do our sign analysis. What's a nice easy value?
That one you don't even have to do like sign analysis. You can just put the 1 in.
We can just do what?
You can just put the 1 in the original thing.
We could, all right? We could just plug in. Okay, so be careful. If you're going to do sign analysis, remember to use the factored form. So 1 squared is positive, 1 minus 2 is negative, and we get a negative. If you are actually going to solve, that's fine too, but make sure you don't try to do sign analysis in the standard form equation. So yes, this one is not too bad because it's just 1 minus 2 is negative 1. Okay, so again, we know that the graph has to be below the x-axis now. Was there another clue that we already had that was going to happen?
Yeah.
What was it?
Goes down one way and goes up the other way, and so
Okay.
the only way for it to go up,
But
unless it just touches the x-axis,
why is it touching the x-axis?
because it changes direction.
What's happening at 0?
Oh, because there's only
There's a multiplicity, so it has to turn. We have an even multiplicity. So before even doing the sign analysis, we should already know this is an even multiplicity. It is going to turn around here and turn back. No, it'll go through. And so go through here, and in the end, just kind of smooth things out. All right, and again, we don't want to have any rough corners. I don't know if I can. There we go. So especially on the turns.
They're so wiggly.
Yes, they are. All right. So any questions on what we've done so far? No? No.
Why did you write the 1 and 2 in the graph?
Oh, just so for the scale. Yeah, because I just used I widened it. So this would be 1, and this is 2, this is 3.
So, I completely forgot what I was going to say. I have a question, I just can't remember.
Okay. I'm sure it'll come back to you. All right. Ready for the next one?
Mm-hmm.
Okay. So we have f of x equals x minus 1 squared, x minus 4, and then x plus 2.
It's 4th degree.
Yes. Everybody catch that? Fourth degree. Are there any questions on how we get fourth degree? Okay. Okay, so fourth means even. And do we have a positive or a negative lead?
Positive.
Positive lead.
We don't have a lead here, right?
No, you've got
There's,
one.
yeah, if
Oh,
you don't
okay.
see one, then
It's
you know that it's positive 1. Okay, so what do we already know about this function? The graph is doing what? Our tails. Both sides are going up. So we know that in the end, we should have this. All right. And hooray, it's already factored for us. So it makes it very easy to identify the zeros. All right, what are our zeros?
1 multiplicity 2.
1 multiplicity 2, and we have 4 and negative 2. Okay, I'm going to go ahead and plot those. So we have a positive 1, positive 4, and negative 2. All right, what do we want to find next? The y-intercept. Okay, so we do f of 0. So 0 minus 1 squared times 0 minus 4 times 0 plus 2. So we get negative 1 squared, positive 1, times negative 4, times positive 2, and we end up with negative 8 is our y-intercept.
Wait, what did we just do?
We just plugged in 0 for x.
Okay.
All right. So negative 8 here.
We already have. We already have like a.
Exactly. So again, I'm not going to do sign analysis on the 2 outer sections because I already know from my rightmost I should be going up, and I know from my leftmost I should be going down. We don't need to do sign analysis in that first section because our y-intercept was there. However, did we already know we would have a negative y-intercept? Because of the multiplicity, okay? So because we have a multiplicity here, oh, I just threw that down. Y'all didn't stop me. This one's supposed to be up. Something wasn't making sense. Okay. Because of the multiplicity, here, we already knew that this should turn. And again, this goes down. And do I know exactly where this turns around? I don't. I'm just going to go ahead and turn it around here. And this is going to be kind of narrow. So we're going to go up here. Okay. Again, we already know there's a multiplicity here, so it should turn around. And again, I don't know where it turns, but again, eventually it will turn around again and go up. All right, so I'm just going to go ahead and extend this up now. Okay. Yes?
I think it's negative and not positive. Like that they're so that the graph is not going through this the x-intercept on 1 and then making like.
Okay, so this one here?
Yeah.
Okay, because again, we have a multiplicity at this point. It's an even multiplicity. so we know it turns around.
Oh.
Okay. So without even doing the sign analysis, this is what we already expect.
Okay.
Again, make sure that you have nice smooth curves, especially at these multiplicities. It's really easy to make it look like a sharp corner, and we want to make sure it doesn't look like a sharp corner. Question?
Wait, so we know that it turns like that because of
The even multiplicity on 1. So remember we said 1 has an even multiplicity.
So does it have to turn down or does they both turn up?
Well, we already started from the downward direction.
Okay.
Yeah, because we had that y-intercept.
Okay.
Okay.
Sorry, the even multiplicity of 1, that, like, what does that do?
It means that the graph turns around. So if you think about it as the graph approaches that point from the same direction. Okay. Here. Still frozen. This button is so sensitive. Okay. So this is on Desmos. So I graphed here an x minus 3 to the 5th. So that's the red one here. A y-intercept of 3. And so it is a multiplicity there. And what's happening is that the graph approaches from 2 different directions. And so it goes through. Same thing, this blue one is to the 3rd power. And so again, it's approaching that -6 from both directions. Versus the even one, it's approaching from the same direction. Right? The two sides of the graph come towards -2 in the same direction. Okay. All right, so the odd ones will go through, and then the even ones are going to bounce back. Okay. So what I want to point out on this one is probably a common mistake I would see here is a student coming and doing this, plugging in the f of 0 to find the y-intercept and say forgetting to square that negative, which would mean you'd get a -1 and then a -4 and then a +2. And that means that the y-intercept would be +8. Okay, and so that means you would end up going 4, 5, 6, 7, 8. And then you go to start putting the graph together, and do things match up?
No, because we want to turn around.
Exactly, because if we already know that this tail should be going upward on the left, and we don't have a multiplicity at -2, this graph should not be turning around in order to go up here. Okay.
It's kind of funny because, like, the incorrect stuff is red, right? So.
Oh, yes. All right. So use all the information that you have when you're putting your final sketch together. Make sure things match up. Okay. All right. So again, here, I'll note that red is incorrect. All right. So how about you guys do these last 2 on your own and with your table mates so you can compare answers.
And is that our goal also?
And no, and then we have finding equations from graphs.
So no, we're going to do like 10, so it's really awkward.
Okay.
So that's fine.
So there's the first one.
E is over top. So you have
All right. And here is the second one.
Wait. No, I got that wrong.
Which part of it?
Does that have to be that narrow? Because mine is kind of wide.
No, I mean it just depends on what value. Like I increased my scale so that 4 is further down. So
Okay.
yeah, because I did each tick mark as a half mark.
Yeah, I did something wrong with the going up right there between the 2 and the 1/2. -2 and 1. -1.
Okay. Okay. All right, so just a couple more that I want to go through. Yes?
Why is the second goal like negative? Because
Why is the second what?
the
Oh, and I just remembered. That's a mistake there. This one? Where?
this between -1 and 2.
Okay, the y-intercept is -4.
Oh.
Okay. And actually, did we even have to sign or solve for the y-intercept on this one? No, because it's in standard form. So remember, when you're in standard form, that last term is going to be your y-intercept. Okay. I'm going to go ahead and skip 3 because we've already done these. And actually, we've done the ones like 4, 2. It's just this one has a multiplicity on it. So I'm going to go ahead and work through that one with you guys. Alrighty, so we're going to write the polynomial function. Degree 4.
Oh, was this like on our quiz? Sort of.
Yeah, you guys had one on your quiz. Yeah, because we've already done these.
Yeah.
Yeah. So the only difference, that's why I didn't do that first one, because it was just like it. So this one is has multiplicity. So, okay. So again, polynomial function. So we're going to set this up f of x. And we don't know what the lead coefficient is because they're not telling us. So when we don't know what the lead coefficient is, what do we put in for it? An a. So start with the a. Okay, now I'm going to look at my zeros. If I have a 0 of -4, what is the expression that comes from? X plus 4. And because it has a multiplicity on it, what should we do with that? Square it. All right. We have a 0 of 3. What's the expression that's from? And the multiplicity means to square it also. Okay, so again, I don't know what the lead coefficient is, so I'm going to solve for it, which means you have to have another point, and the only thing they gave us is a y-intercept of -18. So what does that mean? What is the coordinate? 0, -18. Okay, so we're going to plug those in. F of x, or y, is equal to -18 when x is equal to 0. So we get 0 plus 4 squared and 0 minus 3 squared. All right, so we have -18 is equal to a times 4 squared is 16. -3 squared is 9. All right, and now I need to solve for a, and I don't have my calculator, and I'm looking at 16 times 9 and thinking I don't really want to do that. So we're going to use some of our mathematical knowledge. I know I'm going to take -18 and I have to divide it by 16 times 9. And what happens here? Yes, 9 goes into 18 2 times. I'm left with -2 over 16, which simplifies to -1/8 is our a value. And the only thing left is to put it all together. F of x is equal to -1/8 times x plus 4 squared times x minus 3 squared. And How was that?
Can we make that into a longer one? Like, we could technically do x plus 2 times x plus 2. We do need to do that.
What do you mean x plus 2 times x plus 2?
Like, before you made us write out the whole thing, so we couldn't have any, like, square things, because, like...
Are you talking about simplifying it and
Yeah.
putting it into standard form?
No, not into standard. But, but originally, if there was an x plus 4 squared, we would have to put it into x plus 2 times x plus 2 instead of x plus 4
No, you don't have to do that.
squared.
It's just more work.
Okay.
Yeah. No, we want to decrease work, not increase it, right?
Okay.
Okay. I printed these graphs off for you, and then I made them so small that you can't read the numbers on them. So you'll have to mark them. Didn't realize that till too late. Do you mind passing that to the back table? Thank you. Okay. So for these, what we're going to do is use the image of the graph to come up with the equation.
Which way is the right way up?
At the opposite direction one's first. Okay. I'm going to move this a little bit. Oh, I think I have to move all of that. Okay.
You have a piece of tape.
It's somewhere. Okay. So again, I'm going to use the image. And what do we know based upon what we see in this graph so far? It has to be positive and it has to be odd. Okay, so we know it has to be positive and we know it has to be odd. Positive, odd. I'm gonna narrow that. Okay, and so now I'm gonna look at the graph and figure out things that I know. And I see that I have a y-intercept here at -2. I see I have not a y-intercept, an x-intercept of 0, and an x-intercept of +2. All right, so just like we did before, I take my f of x is equal to, I don't know what the lead coefficient is, so I'll plug in a. And the expression that would give me a 0 of -2 would be x plus 2. And the 0 that would, or the expression that would give me a 0 of 0 is x. So let me put that up front. And then for the +2, that would have come from x minus 2. Okay. So the next thing is to find a point that's on the graph. And we really shouldn't assume, so we're going to pretend that we were told that this is the point on the graph. Yes?
How do you know it's AX and not just A?
Because we have a 0 here,
Okay.
and so we have to have an x term for that. All right. So again, assuming that they told us that -1, 3 actually is on the graph, I'm just going to use that point and plug it in. So y is equal to 3 when x is equal to -1. And then we're just going to go through and solve. So 3 is equal to, I have -1 times +1 times -3a. So that's 3 equals +3a. And so what is my a term? 1. So we'll just put all of that back together. F of x is equal to, and since it's 1, I don't have to include it, so I'll leave it off. Oh, I forgot my lead x. And then we can write it out as x plus 2, x minus 2. But what else is x plus 2, x minus 2? Is it x squared plus 4? Minus 4, yes. So either one of those is fine. The 3 came from this point up here.
Wait, can you just go back down?
That we're saying is in the graph.
Wait, could we have used the other point?
What other point?
you want it in between 0 and 2?
It's 1 negative 2.
Yeah, you could have used 1 negative 3.
But we can't assume that, right?
You can't assume it, yes. So I was saying we're going to assume they told us negative 1, 3. Okay. Ready to look at the next one? Okay. This one's a little more fun looking. What do we know about it?
4 integers.
Okay, it has to be even and positive. All right, so that's something we'll look for. Okay, and again, I can look here and see, well, I have an x-intercept of negative 2. I have an x-intercept of negative 1, an x-intercept of 1, an x-intercept of 2, and I also see a y-intercept of 4, which is the coordinate 0, 4. All right, so just like we did before, we'll set this up, and again, I don't know what the lead coefficient is, so I'll plug in A. And we'll shorten this up a little bit. If I have x-intercepts of plus and minus 2, what's that expression?
Oh wait, isn't it x minus 1 squared to x minus 2 squared?
X minus, well, remember, we have a plus and a minus. We just did it on the one previous. What is it?
X squared minus 1 times x squared minus 1.
Yes. Minus 1 for that one, x squared minus 4 for that one. Okay. If you don't recognize it, that's okay. You can write out each one of those. It's perfectly fine. Okay. And just like we did before, y is 4 when x is 0. So we have 4 is equal to a times negative 1 times negative 4. 4 is equal to 4a, and again, we ended up with a nice simple a value of 1. And so we'll just put it all together. F of x is equal to x squared minus 1, x squared minus 4.
I'm just confused on the x squared minus 1.
Wait, why wouldn't be f of x equals x times x squared minus 1 x squared minus 4?
I did not catch what you just asked. So this part here, if you write it all out, like for this one here, we know it would be from an x plus 2, and the one over here would have come from an x minus 2.
Oh, okay.
Do you recognize it?
I see, yeah.
Yeah.
Could you just write it out?
Yeah, you can write it out. Yeah, that's fine too. Yeah, that's what I was saying. You can write it out. Okay. I'm going to do one more with you. I didn't give you the image of this one, so that's here. Okay, we'll make this quick. What do we already know about this one? Even or odd? It has to be odd. Positive or negative?
Positive.
Okay, and it has to be positive. All right, so we're going to go in and just like we did before, set this up. We don't know what the lead coefficient is. I have a 0 at negative 1 and I have a 0 at positive 2. So if I go to plug those in, I'm going to have an x plus 1 and I'm going to have an x minus 2. What's missing? There's a multiplicity. And how can we catch that? Changes direction. And also the equation we have up right now, what's wrong with it? It's even. We've already established we should have an odd. Right now I only have an even, right? So that's kind of the clue to come back and like, uh-oh, what's missing? And then we see, oh, we've got this bounce here, meaning this one must be squared. Okay. I'm not going to work through the rest. We already see this because we're getting a little low on time. So 0, 4. Again, if you plug everything in, we would end up getting a equals 1 again. Okay.